do is the following questions. We're looking to do 1, 3, 4, 7, 8, and 9. Now, until recently, you were using Pythagoras Theorem, which was which involves sides known as hypotenuse, adjacent, and opposite, where hypotenuse squared would be opposite squared plus a squared. You're also using SOHCAHTOA, sine, cos, and tan. Okay, and that was for right angle triangles. Right angle triangles are triangles that are guaranteed to have a 90-degree angle. Now, in this exercise, however, what you're going to notice about the triangles below is that they don't have a right angle triangle. So none of them are right angled. So in this case, we use what's known as the sine rule, where we say A over sine A equals B over sine B. Now, let me explain what we mean by that. Is you pick a side. So in this question, I pick A to be A. Now, whatever side looks at the, whatever angle looks at the A is big A. So this means I have to make this sine 60. Okay, pick any other side in the triangle. 10 is the other side we know. Then lean across and you have 10 divided by sine 40. Okay, you're in what we call a cross multiplication situation, where you want to get A on its own. So to get A on its own, what we do is sine 60 is divide on the left, which will make it multiply on the right. And that's why it moves to the top. And see all this in your calculator? You put all of it into your calculator. Make sure it says degrees at the top. So you go to Shift Setup. Make sure it's on 3 degrees and you see a D there at the top, okay? And then what you do next is you enter this into your calculator, 10 sine 60. Now this is a length question. What we're going to do is we're going to find out the length of A at the end of this question. So then 10 sine 60 divided by sine 40. And what we get is 13.47. And what does it? Does it want to round it off at all? To two decimal place, length to 2 decimal places. So find the length to 2 decimal places, or find the angle A to the nearest degree. So we either have an angle or a length question. We know that this one's a length question because of the A value is a length, while in question 3 the A value is an angle. Okay, so what we successfully did there is we calculated it as 13.47. Okay, so A equals 13.47. Now in question 3, however, things are different, because we need to find the angle A. So once again, what we're going to do is we're going to use the sine rule, which is in red over here. We're going to pick a side. We'll pick 16. And then we divide 16 by the angle it looks at, which is A. So 16 over sine A. Then we pick 20, and it looks at the sine at the 50-degree angle. So it's 20 divided by sine 50. Now here's what we're going to do here, right? We want to get sine A on its own. It's division on the left, which will make it multiplication on the right. So we get 20 sine A. The sine 50 is division on the right, which will make it multiplication on the left. That's why we have 16 sine 50. Okay, because the sine 50 was division on the right, which makes it multiplication on the left. The sine A was division on the left, which makes it multiplication on the right. We still want to get the sine A on its own. It's been multiplied by 20. So what we can do here is we can divide. We can bring the 20 from multiplication on the right to division on the left. Now we're at the stage where we can calculate sine A. All angle questions end with sine inverse. So if you look at this, you're going to get 16 sine 50. Hopefully all divided by 20. Press equals and you get 0.6128. Now to find out what the angle is, you need to sine inverse it. Okay, so what we do is sine A equals 0.6128. You use what's called the sine inverse button. It's the only way of separating sine from A, cos from A, or tan from A, is you have to use an inverse button, okay? So we go back to our calculator, we press shift, sine inverse, 0.6128, and it tells us that the angle has to be 37.79 degrees or 38 degrees to the nearest degree. So what it's essentially telling us, the sine rule is essentially telling us that in this particular triangle, when one of the angles is 50 and the 50 degrees looks at 20, and another length is 16 and it has to look at a 38 degree angle for that triangle to work. That's what the sine rule essentially tells us, okay? So that's 1, 3. Now we're on to question 4, which is also an angle question. Once again, using the sine rule, a over sine A equals b over sine b. Okay, and on the next thing we have is an angle question. So once again, pick 10. 10 can be small a. And what looks at the 10? The angle I. So it's 10 over sine A. Pick the 12 then, and what looks at the 12? The 75. So it's 12 over sine 75. Once again, division of sine A on the left becomes multiplication of sine A on the right. It has to move up towards the 12. Division of sine 75 on the right becomes multiplication of sine 75 on the left. We want to get sine A on its own. So what we can do next is we can bring the 12 underneath the 10 sine 75, like so. And then we have sine A on its own. Use the calculator. 10 sine 75 divided by 12. And we can find out the angle here. We can 0.8049. Well, we don't know the angle yet. But so this means sine A equals 0.8049. This means A equals sine inverse 0.8049. Put that into the calculator. So what we do here is shift sine 0.8094, 8049 I mean. And there you have 53.6 degrees, which would be 54 degrees. So it means in this triangle, this angle here would have to be 54 degrees to make it work. It makes sense because the 75 looks at a 12 and 10 is smaller than 12, so it means 54 should be smaller than 75. Okay, now we're on to 7. Please remember, when it says QPR, it means you go from Q to P to R, and that's why it's 30 degrees there. PQR means P to Q to R, which would be this corner here. Okay, now the first thing we gotta find is find PR correct to the nearest degree. So call PR A, or you can call it X. Okay, so it's A over sine A equals B over sine B for the sine rule. You should probably pause it now, guys, and have your own go at it. Don't be just copying me all the time, if you can help it. So A over sine 84 equals B, which is going to be 7 over sine 30. Now, we want to get this A on its own. It's a length question, so in the end we should know what the length A is. So what we're going to do here is we're going to bring the sine 74 up. So it's A is going to be equal to 7 sine 84 over sine 30. Put all that into the calculator. So it's going to be 7 sine 84 divided by sine 30. And what we get here is 13.92. Correct to nearest integer is going to be 14. A equals 14. Okay, now another trick we have is that all three angles have to add up to 180 degrees. So the red angle, the green angle, and the blue angle have to add up to 180 degrees. So if we get 180, take away the 30 degrees, take away the 84 degrees, and what we should get here is 66. Okay, so that's 66 degrees. Now we can use the sine rule to calculate what PQ is going to be. And once again, we can call PQ A for this question. So it's going to be A, which is now PQ, divided by sine 66, because the sine 66 is the angle that looks at the A. Then the angle that looks at the 7, because we know the 7 from the previous question, is 7 over sine 30. Some of you could also use 14 over sine 84 if you want. That will also work. Whatever you want to use. You could somebody else could have picked the 14 and you could be using 14 over sine 84. That's okay. You'd get the same answer. So it's all good. So I'm going to use the 7 over sine 30. I'm going to bring the sine 66 up. So it's 7 sine 66 over sine 30. Put that into the calculator. Oh, it's my bad. 7 sine 66 and and bracket, all divided by sine 30. And we get answer of 12.79, and then that'd be 13. So 13, which makes sense. 14 is opposite the largest angle, 13 is opposite the middle angle, and 7 is opposite the smallest angle. That all makes sense. So we've done 1, 3, 4, 7. I think we might call it on question 8, lads. So once again, we have to find the angle P or Q, which is this angle here. We'll call it angle X. And remember, all three angles have to add up to 180. So we get 180, take away the 45, take away the 70. And what should happen is we should be able to find out what the third angle is fairly quickly. 65 degrees. Okay. Calculate the following correct to one decimal place. Q to R. So we'll call this A. So we're going to use the sine rule again. A over sine A equals B over sine B. So what we should get here is pick a side. So we have A. The angle that looks at the A is sine 70. B is 10. And the side that looks at the B is 45 degrees. So sine 45 degrees. Cross multiply up to sine 70. So A equals, this is a length question. We're going to find out what is the length of A, which is Q to R. 10 sine 70 over sine 45. Put all that into the calculator. There you go, 13.29 to one decimal place, because you can see in the question says one decimal place. It's going to be 13.3. Now, for the next question, we'll no longer call Q or A. We know X is 65 now. We'll call Q to P A. So our first answer is 13.3 for QR. Now we're after P to Q, which is A. So it's going to be A divided by, using the sine rule, A divided by sine 65. Divided by B, which is 10 over sine 45. And then what we're going to get is A equals 10 sine 65 all over sine 45. A equals 12.82. So 12.8, correct one decimal place. Okay guys, that's it. So that took 15 minutes. So questions 1, 3, 4, 7